Okay, so our subject matter for today, the theory of structure, abbreviated as CE316, or this is the structural theory. Yun. Okay, so before we dive in with this subject, let us first define what is a structure. So you are already done with the mechanics of deformable bodies, known as the strength of materials. So I want to call somebody who can give me the definition of structure. Please raise your hand. You can raise your hand in it.
Structure is a type of body that has that is solid and it has a defined shape and form.
A solid body with
It
defined
has a defined shape and form.
shape and form. Okay. Okay. Any other idea?
Sir,
What is your idea? What is a structure?
structure is composed of dimensions, shapes,
Mhm.
and shapes.
It's basically a shape.
Yes, sir.
Mhm. What else, Mr. Hello?
One po, sir. Structure is something that is built together that can
Mm,
stand on its own.
okay. So belt together. So meaning, okay, from the word itself, build, built together. Because of the word together, what does that mean? So meron nga built together. So this means that, yes, Mr. Civil.
Yes, sir.
Okay, so what is your idea when you say built together? Bakit together?
Kuan, sir, bagan composed siya of different materials or components na kuan niya gin mix para makabugusin usa nga bagat usa liwat iya nga bagat thing or something.
Okay,
Bali,
very good. So it's actually when we say structure, it's actually a system of connected parts or connected components. So when we say structure, damo ito niya mga components. Parang sa it balay, di ba? It balay may da niya different components. May da niya sinisaring nga beam, may da niya truss, may da niya columns and all, di ba? So different structure or different components built together, or it's a system that is connected together, um used to support a load. Let me write my definition. Okay, so a structure, it's actually a system of connected parts. Okay, parts, meaning damo yang components used to support loads. Okay ha? Amo niya ginsusuportahan permi loads. Amo niya permit aton concern. So it's a system of connected parts used to support a load. Ibig sabihin, ini nga load, amo ini ipagdi-define kung magfi-fail ba or dere it aton structure. So tanan nga study dinhi hit aton hini nga subject, hini nga structural theory. Okay? Tanan nga computations. Tanan nga computations, this will all start from the loads. Okay? Okay, now before we go on, give me some example of structures. Ano ba it mga example it mga structures? Okay, I'll start. We have here what we call the building, di ba? May nakita building. Okay, pinaka-common in nga building. Building is a structure. What else? Structures that is connected or yes, connected ha aton profession as civil engineering. Of course, it pinaka-common din he is building. Building and mga built structure and mga building, high-rise building. Or bisan simple nga balay, di ba? Building na gapiton. What else?
Bridges.
Very good.
Search.
Bridges. What else?
Dams.
Dam.
Ay, okay. Dams. Okay, so what else?
Sewers, sir.
Roads.
roads, sewer systems.
Signal tower.
Pero it's sewer system kasi another specialization or another track hit civil engineering. Damo kasi aton specialization, di ba? May dakita structural engineering, may dakita water resources, may dakita construction management, tapos may dakita damo pa ito niya
Geotechnical, sir.
yes, geotechnical engineering. So damo ito na aton pagpipilian. Okay. Anyway, so I guess mag-aram na kami ibig sabihin its structure. Aton natin tigam na its structure, it's a thing or a system of connected parts. Meaning ibig sabihin damo nga smaller parts or smaller structures, they are connected together and it is used to support loads. Permiton niya loads again sa support. Okay? So, tanan nga computations, tanan nga study, tanan nga endeavor, dinhini nga subject will always starts from the loads. Okay. Now, since nayakan dinhi, the structure is used to support loads. Okay, so when we create or when we design, we are civil engineers man, so we don't just create, we also design. Okay, we don't just construct, we also design. Okay, so when we design a structure, there are several considerations kung nagde-design kita. Okay, so una din of course, pinaka number one is the safety. The safety hit safety hit nagko-construct, safety hit end user, and safety hit tanan, safety hit mga kuan, hit mga end user, hit magamit hit imo structure. Di ba? Now, how can you ensure the safety of the structure? Any idea? Any idea? Anybody?
Sir, quality of the materials used.
Very good. Of course, the quality of the material. Diba? Natural kung ikaw it contractor or this is in the contractor side. If you want to ensure the safety of the end user, you have to choose the best quality material. Diba? Ibutang ko din material quality. Okay, what else?
And
So-
location, sir.
Location. Okay, this is very interesting. Location. Okay, what if Mr. Who's talking again?
Sir.
Mendoza, okay. So what if Mr. Mendoza, you have a client nga it tuna or it location is dahil somewhere not safe or sigunta. Okay, say for example, you have a client wherein the location wherein he or she wants to build his or her house is unstable. Now, what will you do?
Makuhan geotechnical nga engineer.
Okay, that's it. Okay, very good. That's actually my point, Mr. Mendoza. So the location, kung diri nga ni stable, then you have to make engineering intervention. May sinisiring nga mga engineering intervention. So that's why nag-study gyud kita hit other branch of engineering, hit civil engineering, ito niya nga geotechnical engineering. Kasi we want our clients, the end user of our structure, to be safe, di ba? So if you found out nga there is stable and tuna kung diin niya gusto ipa-build an iya house, then you have to make some engineering intervention. Yun, so that's it. You have to ensure the safety. Okay, so ano pa ba nakakapit safety?
Sir,
Ah,
standard
well-
built it mga it is structure.
What
Dari
do you
mga substandard and mga beams makakasupport hand loads.
Okay. Now we are talking when you say diri substandard and mga kuan, diri makakasuporthan loads, enough
Yes,
siya para
sir.
makasuporthan loads, you are actually talking about the design itself. So
Sir,
the design important.
ma-follow ang plan and structure. Like, waray ko lang kay
Ano?
ma-follow plan and structure.
Okay. So we have to follow the plan and structure. Kung sino man nag-design o kung ano man ang nakadan specification, you have to follow whatever is on the specification. Pero dapat you should also have the technical know-how because diri man ito perfect ito nga nag-design. Bisan hinuo nga tao diri man perfect, diba? So do not just blindly follow kung ano it design. Dapat may dakagihap technical know-how kung ano it mga aadhit plano para kung may da man diri kaaya-aya or something you have doubt, you can consult the designer naman para ma-resolve an issue. Okay? What I'm trying to emphasize here is do not just blindly follow. Okay, 'di ba? It aton kasi number one nga concern is the safety. So kita agihap kung ano kung tama ba itaadit plano. 'Di ba? That's why may da kita designer, may da kita engineer di dahit nagko-construct didtohan contractor side. 'Di ba? Para may da sinisiri nga check and balances. 'Yun. Okay, so safety number one, nakakaapekto is of course the material, the quality of the material. Dapat diri substandard and material. Of course, number two is the design. Okay. Now, when we talk about the design, so meron kasi nga nakita nga design, diri ito niya kay an aesthetic part and design, di ba? We're not architecture here, we are civil engineers. So when we say design, we're actually mostly talking about the structural design. Diba? The structural design. So ibig sabihin, when we talk about the structural design, we are talking about how each structural members will respond, how will it respond to the different external forces. So ibig sabihin, when we are talking about safety, you have to consider also the loads. Di ba? Amo man ito net loads. Say, for example, didit balay, didit building. Oh, you have to consider kung pera it mga, ano ba mga loads? Okay, wait lang ha. Parang nagsasagwi-sagwi ako yung discussion. Let's stop at that lang muna. Kasi another topic kasi ang loads. Okay, what I'm trying to point out lang is for you to be able to ensure the safety, you have to consider the quality of the material, of course, the design. Ibig sabihin, you have to consider all the loads, the mga external loads. Okay. Now, another concern it when we construct or when we design structure, another concern is what we call the yan kanina na mention and aesthetics. Di ba? Although we are not architecture, diri man gyud kita ko hit arts because when we talk about aesthetic, we are actually talking about the art side of structural engineering, of civil engineering. Di ba? So, aesthetic, it color combination, it aesthetic, it kabuuan, it pagkita, it imo structure. You should also consider that. Pero it aesthetic, this is not our number one concern because amo ito may dahini another professional that deals mostly about this one, and that is the architecture and the interior design. So but diri ibig sabihin nga as civil engineers we should not consider this ini nga aesthetic. Okay, now another one naman, okay, you have the safety, you have the aesthetic, you also have what we call the serviceability. Serviceability. Okay. Oops. Serviceability. Okay. So ano ba yung serviceability? may kita tinatawag nga design nga sinisaring naton nga ergonomically correct. So, serviceability for example, bawal ka mag-construct in kitchen nga adto'y sulod it CR, di ba? Sugad ba hiton? Serviceability dapat appropriate it imo design it mga rooms or it mga rooms dili kuan dapat nagko-conform dida hit other nga part hit imo balay. Okay? Sinisay nga serviceability. Also, serviceability dapat when you go around did imo structure or it imo client or it imo end user it imo ginkukuan it imo structure dapat your design is ergonomically correct. Let's say for example hit road. Let's talk about road serviceability. Okay, mag-construct ka nga ni road, diri iton niya kay ka-construct la. May dayton mga ginfa-follow nga mga design. Dapat na curve nga ni it imo road, dapat nakuan na pa-imbang kiya, di ba? So ganito, diri hiya dapat plain la it ka-construct it imo road, dapat medyo nakuan hiya nakiling hiya nga di kun naliko ti pakadiha right. Para mga suga dito. That's to ensure, mabalik na naman kita nga dit safety. That's to ensure the safety and the serviceability of the structure nga imoging ko construct. Okay? Yun. Now another thing nga dapat niyo i-consider is of course the economic aspect. Okay, the economic aspect han imoging ko construct. So we have the safety, we have the aesthetic, we have the serviceability, and of course the economic aspect. Okay, mostly we are talking about here han imo clients. Okay? So dapat kung ano ulit available nga resources as civil engineers, you have to make sure na kung ano available nga resources magsasadang ito niya without compromising the safety, the aesthetic, and the serviceability of the structure that you are going to construct. Okay? Economic side. Okay, may kita delete yung mga design subjects. May kita sinisiring most economical section. Okay. Ano ba yun yung most economical section? Let's talk about the most economical section. Okay, a good example of this is beam. Mara naman kami beam, di ba? Okay, a beam and nasupporthan aton slab, beam ito niya tawag. So, maaram ka as civil engineers nga ini nga beam, say the dimension of the beam is, say for example, 200 by 300. Okay, kung maaram ka nga 200 by 300 nga beam is enough na to support the loads that you have previously identified. O ayaw na paggamit hin beam nga mas madako nga masaring ka just to ensure the safety of the end user. It akong gagamiton sobra-sobra hit kinakailangan. Masaring ka magamit ako hit 200 by 400 nga beam. Diba? Yun. What's the use? Ano ba it use nga magamit ka pa hin 200 by 400 nga beam when in fact ang 200 by 300 nga beam is enough naman to support han mga loads, han mga forces, di ba? Ayaw pagsugad. Okay. Basta you should not compromise the safety. Take note, it ating pinaka number one nga concern is the safety of the end user. Okay? Of course, dapat it aton gagamit it most economical section. Meaning, kung enough na ito niya nga section to carry the loads, then there's no reason nga imo pa i-increase ang gasto para ma-ensure nga safety talaga. Usually, it naghihimo hini, it mga diri sure it ira design. Diba? Kung sure ka naman imo design nga enough na ito niya para maka-carry hini nga mga loads, then there's no need for you to increase the the dimension of the beam. Kaya ano, yung mga ni-increase, that's additional number of, kung ano naman, number of bags of cement, number of coarse aggregates, fine aggregates, and all, di ba? Yun. So, dako nga kurata it mawawara han imo clients or kung private ka man, private ka nga private ka nagpa-practice or dapat mawawara ha gobyerno kung ha government ka nagsi-service. Okay, so that's it. You have to consider the economic side. And the last one naman, okay, this is although this is the last, this is one of the most important. Okay? Dapat imo gyud i-consider it environmental aspect. Okay. Imo dapat gin ko consider it mga environmental aspect. Okay. So it's civil engineering. As masters, we can also pursue environmental engineering. As civil engineering ha. So kung graduate na kami civil engineering, pwede ka mo mag-pursue in environmental engineering. Yan. Okay. Let's talk about the environmental aspect kita atin ng structure. Ano ba't ibig sabihin nito? Okay. Every time nga magko-construct ka in road, okay, in road for example, magko-construct ka nga in road didit usa nga forest, you have to secure a permit from the DENR, I think. Okay, may dito nimo yung secure nga permit. Nakalimut ako it ngaran niton. I forgot the name of that permit. Basta may nimo yung secure nga permit nga ginko-quantify, okay ha, ginko-quantify kung pira ka millions. I'm talking about millions here. Kung pira ka millions of wildlife, of mga environmental resources and mawawara darahit pag-construct iton nga kuan, iton nga road. Also, iko-quantify gyap iton kung pira ka million or yes, kung pira an magigain han government or the country as a whole kung ma-construct iton nga road. 'Di ba? Parang ginu-weigh in iton dida an cost nga han benefit han structure nga imo ko-construct. Okay? Sama iton hiya. Ginkukuan iton environmental aspect. Ginko-consider gyapit pagko-construct. Okay. Another example. Okay, kung aada nga ni community, say for example, residential area, residential area, then you are not allowed to construct ito nga mga pabrika, di ba? Kay ada dahit residential area. Kay ano, yun nga, mabalik na naman kita hit safety na naman han end user. Diba, parang mga suga dito nagbabalik-balik la kita ngadtuan aton first nga concern. Another good example gihap, although this is not parang kanan environment talaga, this is more of historical aspect. Pero environment gihap, parang historical aspect hit mga buildings. Diba? Familiar ba kamo hit kuan? Ang building nga ni naging construct didtohan Loyohan Rizal Park, nakikita niyo? I don't know if you are
Yes, sir.
aware of that.
Yes, sir.
Diba? Mga suga diton. That's very stupid nga design. Kay ano ngaging kada hanluyo han Rizal Park, di ba? Mga suga diton. Dapat kamo magdi-design nga ni kamo dapat gi-consider gihap niyo it mga pride ba it historical kuan ba hit kuan hit Filipino as a Filipino. Di ba? So, diri ka pwede basta-basta magguba hinusa nga building if that building has a historical relevance in usa nga community. Yun, diri kahit basta-basta nga magguba. Diri kahit basta-basta nga pwede nga basta-basta nga mag Hello? Sino adto? Okay, anyway. Okay, so amin hera it aton. Okay. Amin hera aton mga concern. We have the safety, the aesthetics, the serviceability, the economic, and the environmental aspect of the structure when you construct a structure. Amo hiyat aton gin kikitaan. Okay. So meaning, okay, out of these 5, okay, we can therefore say when we construct a structure or when we involve ourselves in the design process, we're actually being the design process is actually what we call a creative and technical. Technical here because you have to know the technical know-how kung paano gindi-design it aton mga structure. So dapat creative naman in the sense nga dapat diri man la it aton pagde-design structure diri man la iton hiya kay ka-compute la consider gyud natin the aesthetic, yun it economic, and it environmental aspect. So iton hiya nga may kita sinisiri nga creative and of course technical. So when you involve yourself in the design process, it's actually a creative and technical endeavor. Now, what does this mean? Okay, take note how when you involve yourself in the design process, you have to know the number 1, the fundamental knowledge of material properties. Now, what do you think is the reason why you need to know you have to have the fundamental knowledge of material properties?
I think, sir, we need to know the fundamental knowledge of material properties so that in creating and designing our system for our structure, we will be able to determine if the design that we have created is efficient and is safe para sa mga users sit building.
Okay, give an example of material properties. Now you claim to have finished the construction material and testing. So I believe you already know what are the different properties of material. So give me at least 5, Mr. Abordo.
Ano po, sir?
Properties of material. Common properties of material. Give me 5.
Bending.
Bending. Bending is not a material property. Bending is the response of material to loadings. Okay, let's talk about bending, Mr. Abordo. Why do you think a material can be bent? Kaya ano daw lang nabibend ito sa nga material? Say for example, steel. Kaya ano nabibend ito sa nga steel? What property does it have for it to be able to bend? Yes, Mr.
Because steel is ductile, so that
Ductile.
yes, it is
Very good.
ductile.
Ductility. Okay, so ductility. Ano ibig sabihin ductility? Sige daw, what's ductility?
Can be bent into fine. Can be bent into fine wires.
Come again?
Can be basta nabebend yan.
Malleable ata, sir.
Pero steel should be pero steel is ductile, di ba, sir?
Yes. Steel is ductile. Malleability naman, who said malleability? Hello?
Oh, sir.
Okay, what is malleability, Mr. ano?
It is the sir. It is the ability to be shaped and extended by hammering the material.
Okay, malleability, ibig sabihin, it can be, reshaped. It can be reshaped. Okay. Anyway, okay, let's go back to my original question. Okay. What do you think is the reason why we need to know the different properties of material? So when we design, when we use a certain material in our design, why do you think we need to know the different properties,
So,
material properties of that material? Please raise your hand if you want to answer.
Okay, sir. Since structure is defined as a system of connected components, and one of the component of a particular structure is the materials. So we need to know, or we need to have the knowledge about the material properties so that we will be able to know how a particular material will react when we use that kind of material on the
Very good.
construction.
Very good, Mr. Laplana. Okay, example. Okay, say for example, ductility. Okay, if you know if you know the property of the material, sigunta ductility. Because, okay, di ba, as civil engineers, when we say we know the property of the materials, it's just that dili iton kay maaram kita masaring kita maaram kita nga ductile ito niya nga material. We need to have a gauge, di ba? That's why usually when we express the ductility of a material, we always express it in numbers, di ba? Nakigets niyo? How ductile is the material? So amo itong gini-express natin ito niya in terms of number. Di ba? Dili man it sugad hit. Mahusay ka. Gaano ka man kahusay. Di ba? Rate yourself from 1 to 10. Parang may dakita gin-express natin ito niya in numbers. Okay? Kaya ano in numbers? For us to be able to compute kung masaring kita, amo ini ang ductility han material, amo ini ang number nga nag-represent ang ductility han material. So, maaaring man kita kung gaano hiya ka-ductile, mako-compute naton kung gaano hiya an iya bending when subjected to certain forces. Ibig sabihin, if we know the different properties of material, we can basically predict kung ano it mahinanabo hit aton design. 'Di ba? Amo iton nga nagde-design ka nga ni, it's actually when you say design, you are actually anticipating the mode of failure of your structure. 'Di ba? Let's talk about the beam. Okay, let's talk about the beam. Okay, ano ba what are the different modes of failure of a beam? Give me one. Mr. You are done with your mechanics of deformable bodies, so I believe you already know this, the different modes of failure of a beam.
Flexural failure, sir. Amo na flexural failure tapos shear
Lateral
failure.
failure and shear failure. So let's talk about flexural failure. Okay. So flexural failure, ibig sabihin your beam is subjected to bending, 'di ba? Now, if you know the material property, ibig sabihin kung maaram ka kung ano ang mga property ng material nga imong gamit as a beam, then basically you can predict kung up to nga in kakusog nga bending force it kaya ma-support hiton nga imo structure. Ibig sabihin, parang gina-anticipate mo it mode of failure. O kung maaram pa nga nga magfi-fail ini hit bending, you have to do something about it. Amo na itong sinisalang nga mga engineering intervention. For example, it concrete. Okay. It concrete, nayakan it construction material testing. You have found out if nag-conduct talaga ka man experiment, which I believe why. Nayakan it concrete, basically, a concrete daw has a very high compressive strength, and very low, and in fact, sometimes negligible, very low tensile strength, di ba? So, very high in compression, but very low in tension. Kay ano man naging gagamit naton iton hiya hit construction as construction material when in fact we know naman nga very low hiya in tensile stress. And we know that a beam is subjected to bending stress, and basically that means that your beam will be subjected to compression and tension. So kay ano man gagamit natin it concrete nga mahini man hiya tension, 'di ba? Since you know nga mahinay it concrete it tension, mahinay it iya tensile stress, amo iton nga nag-devise ang mga engineers and mga scientists sinisiring naton nga engineering intervention para ma-counter iton nga kahinaan hit concrete, di ba? Amo iton nga may kita sinisiring nga reinforced concrete. Reinforcement hiya because nagbubutang kita hin bar, reinforcing bar, ang mga kabilya ba? Ginbubutang naton hiya didahan han beam, han concrete because of that fact nga it concrete mahina yung heat tension. Diba? So kumbaga an bar adto nga bar amo iton hiya ang nagki-carryhan mga forces nga supposedly gi-carryhan concrete when it is subjected to tension. Diba? So nag-anticipate ka, gin-anticipate nimo nga magfi-fail an concrete, I mean an beam due to tension, then you do something about it, nag-introduce ka hin reinforcement and bar para maiwasan nimo adtong kind of failure, di ba? So basically when you are designing, parang gin-anticipate nimo it mode of failure, then when you already know nga magfi-fail iton hiya, nag-introduce ka hin solution to your whatever it is nga imo gin-anticipate ang mode of failure. Okay, so amo iton hiya. So basically, when you involve yourself in the design process, so when we say design process, you are actually being creative. Okay, being creative and technical, and that means that you have to know you need to have the fundamental knowledge of the material properties. And I think you already know this because you are already done with construction material and testing. That's why you cannot take this subject if you fail on that. Okay. Ang ikaduha naman, of course, maaram ka na han mga mga material properties and mga properties and material. Another thing that you need to know is kung paano magre-react. Okay? So we are now talking about the mathematical equations nga nagga-govern kung paano ang relationship, ang reaction, ang material ngadtuhan input or ang mga loadings nga gin-a-apply nga dahan material. Diba? Okay, so ito nga mga relationship or ito nga mga ito nga mga relationship nga nag-govern kung paano mag-react ito sa material. Dito natin nababaruan hit an aton strength of materials, and dito na strength of materials an aton ginstudihan are the different laws of mechanics. So mechanics, damo nga branch it mechanics, may kita statics, diba? Statics, may kita mechanics of deformable bodies and dynamics of rigid bodies. Okay. So tutuloyin hiya. Dapat tanan na ini matutulong ang mechanics iyon na natapos. Pwede kitaan statics. Ang statics, okay, ang iyong studihan ng statics, ito ang mga statics, ibig sabihin bodies not in motion, bodies that are not in motion, static stationary. So usually ang iyong mga gina-adman dinhian pagkukuhan mga resultants, diba may nakita x and y axis as may na mga different forces, dira mga forces tas kukuha nato ang iya pinaka resultant. Diba? Nanumdum ka mo iton. Amo itong didaan niya gin-studyhan ng static. Now, please don't forget ini nga mga topic nga sugad hindi dito niya static. Kung nangalimtan mo na review kay damo ini iyo pagstudihan dinhi. Damo it mga sugad hindi dinhi theory of structure. Then the other one naman is the dynamics of rigid bodies. Okay. Dynamics of rigid bodies, amo naman yan, movement of particles or movement of bodies on space. Example ini is moving car. Ba? Moving car, dynamics. Amo ito niya. Dili kasi ito nato niya kung anan car. Usually kasi aton kasi mga tawag ini, aton mga structure are stationary naman, di ba? Aton mga structures. So less it yung magagamitan din nga dynamics of rigid bodies in this subject. It pinakadamo nga yung magagamitan is the mechanics of deformable bodies or sometimes called as the strength of materials. Strength of materials or the mechanics of deformable bodies. Amin hiya dinhi. kumbaga di din ang static, stationary, di din dynamics nagmo-move, di din naman strength of materials. Ang ginme-measure dida ang mga elongation, di ba? Ang mga elongation, if you are familiar with this one, ang mga elongation and mga stresses. Okay, okay, elongation na however small, ginme-measure naton ito niya. Kasi in reality naman, when you measure the deflection and pagsasagit beam, di ba? Pagsasagit beam. In reality, you cannot see that in your naked eye, it pagsasagit beam. Pero aada talaga ito niya, present ito niya nga pagsasagit beam. So may nakita, excuse. May nakita mga allowable deflection, mababaraw ulit niyo as we go along with this topic. So, amo itong dapat ito yung mabaruan. So, duduha ha, dapat when you are involving yourself in the design process, you should to know the different fundamental properties of materials and of course the laws of mechanics. Yun. Okay. Now, how do we design? Okay, in the design process, in the design process, what do you think it pinakauna? Say for example, it pinaka-simple na lang, nagdi-design kita beam. Say for example, nagdi-design kita beam. Okay, what do you think it pinakauna nga step hit pagdi-design beam? Anyone?
Answer determining of
Yes. Hello? Sino adto?
Compute and load, sir.
determination of loads. So,
And
Who's
loads.
talking? Who's talking? Tabusap. Tabusap ka?
Yes, sir.
Okay. Loads. Okay. Nayakan. Sige ha, nagdi-design kita beam. Okay, nayakan ni Mr. Sabusap, load daw, it aton kailangan una nga i-determine. Okay ha? Please follow me on this para dili kita magbalik-balik. Load daw, nayakan ni Mr. Sabusap. Okay, Mr. Sabusap, what do you think are the different loads nga dapat aton mabaruan when we are designing a beam, ha? Beam, itaton gini-design, beam.
Kwan,
Okay.
sir. In
What are the
slab.
different ha? Hello?
live gun dead loads, sir.
Live load. Okay, very good. May nakita live load.
Dead
Okay.
loads, sir.
Of course, the dead load. Ano pa? Live load, dead load, what else? Di ba nag-design kita beam? Ano ba yung mga forces? Ano ba yung mga forces nga nag-aak dida hit koan? Dida hit beam. Okay. Ano niya? Live load and dead load. Okay. Now, let's talk about live load. Ano is mga included in it live loads? Mr. Sabusap, I'm still talking with you.
Sir.
Example of live load, Mr. Sabusap.
Kwan, sir. Mga people.
Yes.
Tapos, pwede kayo consider mga kwan, sir. Mga vehicles, furnitures.
Oh, furnitures na la. I can't vehicle. Kaya balay ada itong kuan. Nga beam tat gin-istoryahan. Residential la. Furniture na la.
Sige, sir.
Okay, what else? Live load. People, furniture, ano pa?
Ano pa, diba?
Anything that can move, right? Basta anything that can move. Okay, so let's talk about the dead load naman. Mr. Sabusap pa rin. Ano yung mga dead loads? Give me one. Hello?
Kuan, sir. Sugad trusses.
Kaya, okay. Wait lang.
Tapos,
Wait, akong ginistoryahan. What do you mean? Kaya ano may truss? Unweight hand
Ano, sir?
truss.
Yes, sir.
Harvest and beam.
Yes, sir.
Okay. The weight of the truss nga na
Nakuha beam.
you mean to say that the beam supporting the truss.
Yes, sir.
Okay, so ibig sabihin an weight hand truss ging carry hand beam. Okay.
Yes, sir.
Pwede. So weight hand
Kuan.
truss on the
Roof. Kuan gap, sir. Roof.
trusses. No,
Roofs.
it truss kasi asyet nakuanhan beam. I'm sorry, han roof. Asyet na support han roof.
Yes, sir. Oh.
Tapos an na-support naman han truss and beam. So okay na ito nga weight of the truss. Upod na ito didaan roofing. Or in general tanala diri nala truss.
Kuan,
Weight
yeah.
of roofing.
Roof. Tapos, ceiling.
Roofing. Ceiling. Pwede, yes. Pwede gihap. So we're talking about roof beam. We are talking about roof beam ini. Okay, wait lang. Simplihan ta lang ha para diri kita magkuan. Let's talk about you have a two-story house. Tapos ang beam nga aton gin design is the beam on the second floor. And beam na support ang second floor. Okay, let's talk about first. Para diri kita magkuri kay nagkukuan kita ibaan akon beam nga gini-imagine tapos ibagay ako nga beam mo gini-imagine. Okay,
Sige,
let's
sir.
talk about that first. Okay, what are the dead load? Example of dead
Kuan,
load.
sir.
And
Floor and second floor.
slab. We call it
Slab.
slab.
Oh, slab.
Okay.
Tapos,
The weight, the slab. What else?
and walls. Walls and kuan. And
Walls.
mako-consider ba, sir, ang plaster and pagkuan? Pero ada na tiyat walls, di ba?
Plus, ano na itiya? Pwede na itiya. What else?
And kuan, and roof, sir, han second floor. Okay, di ba?
No. Nakitahan beam, han second floor. An beam nga na-support han second floor. Slab, the walls. Walls on second floor ha. We're talking about the walls on second floor. Ano pa? May tidak usa nga akong ginbibiling nga gusto ko nimo ma-mention. Because that's very crucial kung ano talaga una hit design process.
Columns.
Structural load, sir.
Columns supports the beam. So you cannot put the beam before the column. Kahit column, asyet na support it beam. So all of the weight na supportan beam will be supported by the column because the column supports the beam. And it's not the other way around. So when we talk about the beam, ano ba itong mga dead load nga na support niya? Okay, that's correct. You have the slab. You have the walls. What else? Number 4. Mr. Sabusap.
And self-weight and beam, sir.
Very good. Self-weight of the beam. Okay. The weight of the beam itself. Or self-weight na lang. Self-weight of beam. Question, Mr. Sabusap. If you are going to find the self-weight of the beam, 'Di ba? Can you find the load even though you still don't have the dimension of the beam?
Uh,
Okay, ini nala.
yeah.
Ako nga pakiana. How can
Sige,
you
sir.
find the self weight of the beam?
And designhan ko sir. And designhan ni himuon nga beam nga makasuportan.
Okay, 'di ba? Okay. You need the design of the beam. But you said in the design process, pinakauna is the determination of the load. Then how can then you find the self weight of the beam if you say that the design of the beam is needed for you to be able to find the self weight of the beam? Nagigits na yun akong punto? Hello? Hello? Mr.
Yes, sir.
Okay, what is my point?
Sir, nag-direct man largo, sir. Ano sir, na-process pa.
Ha?
Na-process pa, sir.
What do you mean? What do you think? Okay ha. Nakan kasi nakan hi Mr. Sabusap in the design process. Ibig sabihin na nagde-design ka. In the design process, pinakauna nga the first step daw is to find the loading, basically the loads that are acting on the beam na natin gindi-design. Okay. Pero nayakan hi Mr. Sabusap, for you to be able to find the load, kailangan i-determine mo ang dead load. An example of the dead load is the self-weight of the beam. Then for you to be able to find the self-weight of the beam, you need to know basically the dimension. The dimension of the beam. How can you find the dimension of the beam when you still don't have the dimension because uunahon nimo ang load? 'Di ba? Okay. So what I'm trying to point out is diri load it una ang determine. Okay? It una nga determine, it una it design process. It giuunahi talaga is what we call the initial design. Okay? Asya it pinakauna. It pinakauna is the initial design, not the loading. Okay? Diri ito niya it giuunahi. It giunahi talaga is the initial design. May gusto nimo mag-create in beam. You have to start somewhere. Initial design laanay. Then what will you do with the initial design? Let me call in Mr. Sempron. Mr. Sempron,
Yes, sir.
what will you do with the initial design? What's the next step?
Hala. Mm. So, on initial design, sir, on bagay intake, ang dimensions, ano, sir? Clarify ko lang po.
Mhm.
Intake ang dimensions sa beam lagi hanggang beam lagyap ini, sir, or
We're
overall
talking
structure
about the
na
beam. We are talking
beam
about the
lagyap
beam
pa.
lang.
So, kung kuha na niya dimensions.
Okay, so when we talk the design, when we are talking about the beam or the design process, the first step is always to have the initial design. Then what will you do with the initial design? What's the next step?
Actually, sir, oray ko po na hunahon, sir.
Actually,
Sorry,
di
sir.
ba? You have the dimension na when you have the initial design, you already have the dimension. You already have the self-weight of the beam. Makukuha mo na ang load. Makukompute mo na ang load. So the next one is computing the load. Okay? Computing the load. Ito na ikaduha. Okay. Okay? What's the next after computing the load? What do you think is the next? After you quantify, after you know the different loadings, what will you do?
I-revise na sir ang initial plan.
Diretso There is so initial plan, i-revise na initial plan. Computing the loads. After compute ni mula ang loads, diri naman. What will you do with the computed loads?
Kami ga-apply ba?
Ano ibubuhatan na imong compute nga load? Oh, nasa ring naya kang kita may dead load, may live load. O anong kuman iton nga dead load ngayon live load?
Analyze for the distribution of force.
Distribution of force. Come again? What's your word again? Ang distribution of force?
The analyzer.
Analyze. Okay, but before you can analyze, actually yes, analyzation na ito niya. But before you can analyze, okay, that's a very good idea. But before you can do so, if unahin mo nga di-determine are the reactions. The reactions and ang mga kung paano ba mag-perform an imo ko. Yes, analyzation night. So reaction it imo ginkukuan. Compute. You have to compute for the reactions. Kung ano ba ang mahinanabo han mga material nga imo gamit when you have the external forces, the computed load na. But you have the initial design, then after the initial design, you compute the loads. Then after you have quantify, you have know the different loads. You have to solve the reaction. Ano ba it magiging reaction han mga material? And that includes the related kay anka reaction han at the supports. And that includes the performance of the material itself. Kung gaano ba gaano ba hiya kadako an elongation or gaano ba kadako an pagsag han beam when it's subjected to forces. Diba kasi if you have a beam, pananglitan you have a beam, and if this beam is subjected to forces as may already support, diba? So tendency niya is to sag, diba? You have to know kung pera iton nga sag, amo iton din hit imo ginkukuan reaction. Diri ilaan mga reaction at the support, kanya ni nga mga reaction, diri ilaan nga mga reaction. But also ang tanan nga reaction, ang tanan nga nahinanabo internally, externally, didahan imo han imo structure, han imo member. Okay? Han imo material nga gingamit. Okay? So amo ito niya. Gidetermine nimo its reactions after computing the loads. Then after the determination of the reaction, you perform the analysis. Okay. Perform the analysis, tapos masugad. Gin-analyze nimo. Then it was found out that your initial design is not enough to carry the in your analysis, it was found out that your initial design is not enough to carry the computed load. Ma-revise ka na naman nga din mo design. Di ba? Ma-revise ka mo design. Then the process will begin until makuha nimo an nakita sinisering nga most economical section. Ha? Hello? Sino adto? And of course, we also have the most efficient section. Okay, may nakita most economical section and the most efficient section. Yun. So amo ini aton pinaka ultimate goal. Makuha naton ang most economical section and the most efficient section. The action verb is invented. Yun. So it's actually revise lang when we are involving ourselves in the design process. Okay, so that's how the design process works. Okay. Now, let us identify. We still have time. It's 7:08 p.m. pa lang. Okay. Let's talk about the different types of loads. Okay ha? Didikitahin nga mga loading lang. Okay. Loads. Ano ba yung mga different types of loads? Of course, we have the dead load. And we have the live load. What else do we have? Ano pa is mga different
Snow loads, wind loads.
snow load, but snow load is not applicable here because wala mas snow haton. Diba?
Wind loads and
Wind load,
earthquake loads.
Wind load lugod. Wind load,
tapos earth.
Earthquake loads.
earthquake. Earthquake load. What else?
Imposed loads.
Imposed load. What do you mean by imposed load? Superimposed load. Superimposed load actually can be a dead load, live load, or a
Live
wind
loads.
load. Okay, so what else? May nakita lugod impact load. May nakita impact load due to impact. For example, may nahuhulog nga kuan. Diba kung mas taas ang kahulog, mas dako ang impact load kontra kung habubulahan na hulog. So may nakita mga impact load. Okay, so let's focus hindi nga upat lang muna. Ini nga dead load, live load, wind load, and earthquake load. Usually earthquake load diri pa nga natin makukuan din. Hindi nga totoo. Pero let's include that lang muna. Okay, so aman nga ang different types of load. Pero dire lang niya amo ha. Okay. Wait lang. Let me read to you the different types of loads. Okay. Let me read to you the live load. Okay. Nakan didi hit akon kodigo. Nakan live loads daw can vary both in their magnitude and location. They may be caused by weights of object temporarily placed on a structure, moving vehicles, or natural forces. The minimum live loads specified in codes are determined from studying the history of their effects on existing structure. Usually, these loads includes addition protection against excessive deflection or sudden overload. Okay, so and various types of live load will not be discussed. Okay, anyway. Okay. Ang definition nag-mention hiya nasa na ba yan? The minimum live load specified in the codes. Nag-mention hiya in codes. Kaya ano may nakita sinisering nga mga codes. Okay. Okay, let's go back kanina aton discussion. Wait lang. May dako nangalimutan. Okay. Balik kita nga didihan safety. Okay. Ini nga safety, since this is the number one concern it aton structure, it aton design. Okay, this is actually governed by what we call the codes. Okay? This is governed by the codes. May nakita sinisiring National Structural Code of the Philippines. We have the NSCP, the National Structural Code of the Philippines. So amo niya it nagagovern ini nga kuan. So to ensure the safety, okay? Para ma-ensure talaga its safety, may dakita mga sinisiring nga mga minimum requirements. Okay? May mga minimum requirements gagin set dahil National Structural Code of the Philippines to ensure its safety hit mga end user. because the safety is not just the concern of the designer, of the engineer. It is also the concern of the government, of everybody actually. That's why may dakitagin pa-follow ang National Structural Code of the Philippines. Amo itong dida makukuha an aton different codes, okay? Ito nga mga codes, ano ba itong mga codes dida? Usually, it add National Structural Code of the Philippines ang mga sinisiling natin ng mga reduction factor, mga factor of safety, okay? Nagko-compute nga ni kita live load. Okay. Nagko-compute nga ni kita live load. Okay. Balik kita nga di. Saan na ba yun? Okay. Live load or dead load? Okay. Para ma-compute natin live load yung dead load, actually may nakita pa-follow nga design philosophy. Design philosophy. Design philosophies. Okay, may nakita ba ito? LRFD, and diba nasa ASD. ASD. Ano ba ang LRFD? Balik kita nga din ako. Okay. Nayakan di. Okay. In ASD, okay, let me take a screenshot. ASD ngayon yun. Okay. Nakanilid ESD. The allowable stress design or the ESD method include both material and the load uncertainties into a single factor of safety. The many types of load discussed previously can occur simultaneously. So, hindi nga mga different types of loads. This can occur simultaneously. Okay. Simultaneously on a structure, but it is highly unlikely. Ibig sabihin, there is a possibility nga magdudrungan ang era pag-occur, pero very unlikely nga mag-occur. Pero, as civil engineers, since the most number one concern is the safety of the end user, we have to anticipate na all of the time, anticipate that all of the time, ito nga, the different types of loads will occur simultaneously. Magdudrungan hera. Okay? Although it is very unlikely, but for us to ensure the safety of our end user, we have to anticipate nga magdudrungan ito niya. Diba? Okay, that's why may nakita sinisiring din nga load combination. Okay, this is very important. Okay, for the very updated it aanhin. This is actually the dead load and the wind load. Okay, for dead load lang, okay, combination, dead load, so what niya factor of safety, but when the dead load and wind load, magkuan nga ni magdungan and dead load and wind load, amin yan mga factor, 0.6 and plus 0.6. And dead load naman ng earthquake load, 0.6 nga 0.7. Okay. So, paano ba yung niyaging gagamit? Eh, di ba may daka initial, balik kita nga ito aton kuan, hanaton design process. Di ba may daka initial design? Okay. Madani mo an initial design. Okay. Dilan mo initial design, itatry mo ang dead load, tapos kung kaya niya ang dead load ma-carry, then you don't have to do anything. You don't have to revise. Oh, of course you have to revise gihap because it could be nga an imo initial design is too much for the dead load lang. So you have to revise. Ma-revise ni mga initial design nimo. Then kukuha mo na naman ang imo initial design, imo naman itatry an yan nga combination. Di ba? Tapos of course ma-revise nimo. Inya nga combination ang imo gamiton. So may daka na naman another set of design. Okay, tas kukuha mo naman yung initial design, itatry mo na naman ang yan nga combination naman. Diba? Tas may daka na naman another set of design. So all in all, makakatulog ka pag revise. Diba? I mean, makakatulog ka yung design. Okay. Dito tulong nga result. Okay ha? Dito tulong nga result. Kikitaon nimo kung hain didaan most likely pinaka-safe. Ibig sabihin, handin nga tutulong nga combination, hain dida it pinaka-critical. Okay? The word dida is critical. Hain dida ang combination ang pinaka-critical. Ibig sabihin, kung mag-fail man ang imo structure, hain dida it hain nga combination it makaka-cause an failure. Okay? So, for example, nakita nimo nga yan nga second combination at makaka-cause ng failure. Then you have to follow that design. Okay? Ading design ang imo ipa-follow. Ang design nga kinalabasanhan yan nga combination. Okay? So that's how you use the different load combination. Usually didahit staad, I don't know if you are familiar with this staad. This staad, tanan na iton nga load combination, iyan na iton kukuan, iyan na iton calculate. Or sometimes you have to specify that kung ano nga load combination it gusto nimo i-analyze niya. Okay? So kung for example nag-failure din, you have to revise. Parang revise lang ito it design process. Okay, so for ASD amin hiya it mga factors. May nakita sinisiri nga mga factors. This is the allowable stress design. We also have what we call the LRFD, or this is called the load and resistance factors design. Okay, let me take a screenshot. Here, let me put it here.
Let's check lang. What I'm thinking kasi is, like for example, string 1, 2, 3. I think that's the check lang.
Philosophy to do LRFD and ASD. For LRFD, or this is the load and resistance factor design, since uncertainty can be considered using the probability theory, therefore has been an increasing trend to separate material uncertainty from load uncertainty. This method is called strength design, or the LRFD. For example, to account for the uncertainty of loads, this method uses load factors applied to the loads or the combination of loads. And this is according to ASCI. This is the American Structural I don't know that, basta ASCI. It aton NSCP nakabase in here din ini nga mga standard. It aton National Structural Code of the Philippines, based ito niyahan mga American nga mga mga standards, mga American standards. Yun. Okay, so these are the load factors. Okay, may nakita mga combination for dead load lang, ang niya factor is 1.4. Gini-increase natin talaga an aton dead load para in case nga ma-reach niya an dead load la niya, may dapa niya sinisiring factor of safety. It can still support additional load even though na-reach na niya an dead load nga aton gin-specify din because of this factor. Diba? Okay, now, may lagay kita combination. Actually, this is outdated. So, as we go along with the topic, makukuha niyo sasabtan niyo. I'm just giving you an overview kung ano ito ng mga different design philosophy. So, no need to memorize this. Okay, so, same nga how, ano ba gamit paano yun magagamitan? Same nga how, madali mo initial design, tapos itatry niyo man yan kung mag-fail nga revise, or kung di man mag-fail, revise also, for you to be able to find the most economical section or the most efficient section. Okay, tas itatry mo gapan nga combination. Tanan nimo itatry tapos kikitaon nimo kung hay most critical nga load combination. Tapos kung ano man ang result nga design, amo ito yung igpa-follow. Yun. So that's how the design process work. Okay, so ito niya excuse me. These are the different types of load. Okay, and the different design philosophy or the design design philosophy, the LRFD and the ESD. So for the entire entire duration of the subject for the entire semester, amon hiya it aton pag-studyhan. Okay? Of course, we'll be studying the different types of structures. And we'll start at, ano ba ito una? Saan ko?
No, it's not Lord. That's not the direct
It pinakauna is, pinakauna is beams. Okay. Yun. So, it pinakauna is, let me put it here na. Okay, let me put it here. Okay. So, ito na lang pag-studyhan. Ito ng mga design process, tapos ang pag-analyze. Okay, una ho natin ang beams. We also have plane and space trusses, cables and arcs, plane frames, tapos influence lines for reactions and internal stress resultant due to moving loads. So, amin here. And of course, we will discuss the different ways how to analyze a beam, plane and space trusses, cables, arcs, plane frames, and ini. Okay, so amon niya ang mga different structure nga aton i-consider, i-discuss in this subject. And of course, the different ways to attack them or to solve them, to analyze them. So amo ito hindi na aton ko it aton i-discuss ini din nga subject, structural theory. CE 316.
Sometimes,
Okay.
give you that one with kind of
Any question? I will end my lecture here,
Sir,
my orientation. Do you have any question?
sir, question po. Excuse me, sir.
Yes, you are
Question po.
excused.
Ini po sir nga recording, are we allowed to receive it? Or private la po inihain niyo po nga recording?
You are allowed naman. Di ba kin-add ko ikaw? O ikaw na lang
Sir.
mag-kuan nit imo kuan.
Sir,
Or
ayaw sir, kay
Ilokot
itam
ikuan ko
inet.
nala. I-link ko nala kadto sa Google Classroom. Ipa-public ko ini nga video tapos ililink ko nga sa Google Classroom. I-link namon ni Ramam sa Google
Okay po,
Classroom.
sir.
Maghatag ako iyo video, by the way, wait lang. Maghatag ako yan video. This is a recorded video adto sa YouTube because this is not the first time we handle this subject. Nag-handle na kami last time together with Ma'am Rina and Ma'am Arjane. So may kami recorded video. Ihahatag ko iyo ang link. You have to watch it. Okay, an amon orientation, basically an amon orientation. So kung may dani yung question, please ask your question preferably dito ha Google Classroom publicly so that dili magre-repeat it question. Ini pangayan ha kay danay damo nga student it napakianahit the same question lang tas malipong pag in-answer. So mas mo pa connect question dito nala diretso hit kuan hit public para mag-answer nga ni kikitaon na dayon hit tanan. Okay? So most preferably, please ask your question publicly in the Google Classroom para diri kita. Kaya di na ka mo mag-ask it kuan, di na ka mo mag-ask it Messenger, natatabunan hiya. So diri na natin na-recall mo. Kung dito sa Google Classroom, madali lang pagbiling. Kung meron mo question, makatukol iton dito nga topic, tapos banging ginpakian na nga ito nga question, then yun, madali lang pag-navigate. Okay? Any other question?
Sir, sanala, sir.
Sige.
Sources po, sir. Like, may da po ba natin nga, like, references na books?
May da. Okay, let me share it to you. The suggested resources from CHED. It's here. Can you see it?
Ambot it iba, sir. Haak, waray.
Hindi mo nakikita?
Haak, sir. Ambot it iba, sir. Ambot kay itaknet giya po, one bar la.
Nakikita ko po, sir.
Nakikita, sir.
Nakita, sir.
Nakikita,
Heber, Structural Analysis, 9th edition. Prentice Hall. We have the Introduction to Structural Analysis and Design by John Wiley and Sons. And Otkosinol Norris CH and Wilbur JB. Elementary Structural Analysis, 4th edition.
Sir,
McGurl
screenshot ko na, sir.
Okay, I suggest you use this one, Structural Analysis 9th edition by Hebler, I mean. You can find it in PDF Drive. PDF Drive. Maaram kami PDF Drive.
Yes, sir.
Di kawit maaram ibalog ulit yung mag-aram nga mga site. PDF Drive. Okay. Any other question? Sige na, we still have 30 minutes. Pakiana ka may question. Dalod diri daw napakiana. So maupay adam ka discuss.
Excuse me,
Clear
sir.
pa ka discuss? Yes, Mr. Laplana.
Sir, will you still be sending the syllabus of the subject?
Yes. Ma'am Arjane is preparing the syllabus of the subject. We'll upload it in the Google Classroom.
Yes, sir.
Okay. Okay na. Regarding with the topic, naintindihan ba niyo? Parang yes.
May dagihang grip, sir.
Yes.
Okay man, sir.
Okay ba? Yes, Mr. Liorag, do you have anything to say? Adore. In-close na lagod and mic, Mr. Liorag. Okay, sige, if you don't have any question, please open your
Yes,
camera. Yes, you are excused. Who's talking?
Yes, regarding po, sir, to answer, class,
Nagyayakan.
po ba taton nito? Alberca, sir.
Alberca.
Ay,
At aton meetings po ba, sir, once a week lahiya? Or pera ka days in a week?
Twice a week, as mentioned earlier.
Thank you, sir.
Okay na. Open your camera if you don't have any question na. Mag-take lang ng screenshot for our monthly accomplishment report. And also, I need to see your faces, your beautiful and handsome faces. Balitaw. Hi na. Okay. Mag-loading lang yan on my end. Hi na iba. There are 50 students, pero okay. Nag-loading lang yan. Okay ha. By the way ha, a fair warning. Okay, ikaw natin it-record. I-stop natin it recording.